We'd like to evaluate this integral from 1 up to 2. It appears to be a substitution because we have an inner function. We begin in the usual fashion. Let u be the inner function. Its derivative, du dx, is 1. That means that du is 1 dx. In other words, dx is going to be traded for du. If we go to set up the substitution, this would become u to the 1/2. The dx becomes du. But we still have an x, and we need a substitution for it. This happens on occasion that there's extra expressions in the integrand. Look back to the original substitution, and if we solve that for x, we get u plus 1. So if I simply add 1 to both sides, u plus 1 is the same as x, and that's our replacement for x. As is common, we'll then have to look for the new limits of integration. If these refer to x, I put a 1 in here, and u becomes 0. If I substitute a 2 in for x, of course u becomes 1. And we have our new limits of integration that refer to the new variable u. Makes sense to do some algebra here and distribute the u to the 1/2 into that group. I will then have u to the 3/2 plus u to the 1/2. We integrate each of these using the power rule. U to the 5/2. Again, rather than dividing by 5/2, let's multiply by 2/5. U to the 3/2 times 2/3. We still have to do the substitution from 0 to 1. If I put a 1 in place of u, it should be obvious that I get a 1. That will give me 2/5. If I substitute the 1 here, I will get 2/3. If I substitute the 0, I will get 0. We can continue to do the arithmetic. Getting a common denominator, we end up with 16/15. Of course, here we'd multiply top and bottom by 3, multiply the numerator and denominator here by 5. We'd then have the LCD of 15, combine them to get 16. Once again, this represents the area underneath this function from 1 to 2.